Alright, the second thing I really wanted to cover besides SSH is where you are in the file system and how the Unix, Linux, Mac OS file system works. Now on Windows you have these drives, C colon, D colon, H colon, and you can change drives in the PowerShell or by typing in something like H colon and switch from your current drive C colon to H colon. Unix is much more uniform. It doesn't have a distinction between drives and paths on a drive. Okay, the top of the entire tree starts out with a slash. So if I say slash home, what I'm saying is I'm starting out at the top of the tree of files, and I'm looking in a directory called home for another directory called pschlump. And if I go in my Unix system and do this, what we're going to see is on Mac OS, if I do pwd, okay, I have this big long users, Philip, go, source, GitHub, all the way down. This is my path. If I go in on my Mac or on my Linux system, this is the virtual system. And I do the same sort of thing where I say pwd in my home directory, it'll be home pschlump. Your account probably is different. So that's where you're starting out when you first log in. Now let's create a file and let's look at some things like files and paths and permissions. When I do this angle bracket and pointed example, what I'm taking is the output of ls and I'm sending it to this file called example1. And it gets created with the default permissions for that kind of a file. That's called a pipe. And pipes in Unix are the best example ever of a good software reusability system. Because you can not just pipe to files, you can pipe to other commands, you can chain things together into bigger pieces. So this first one is just piping standard output. That's what comes on the screen. If I just do ls, I get standard output, and in this case I've sent it off to this file. So if we cat example1, we'll see what's in the file. You notice it came out in a slightly different format than it does on the screen. My screen is set up to do colors and multi-column, whereas when it goes to a file it puts it in one column. Now the second thing there is cat, which just copies a file to the output so you can see it. Why it's called cat is because you can take multiple files, copy them to output, pipe them to a single destination, and concatenate files. So let's take another file and let's build this one, a file. Let's do ls minus l. Options in Unix usually start with a minus and a letter, or a minus and a series of letters. And let's put this in, Bob, this is a file. Now when I do ls minus l, we see it like this. If we cat Bob, and I hit Bob and a tab there, okay, and it filled in the file name for me, and I see that I have a list of files here. Most of these lines start with the letter D. That's right there. That indicates that that particular kind of a file, that line right there where it starts with a D, is a directory. A directory is just a special binary file. It's a file. You can do things like just cat a directory. You won't like the results because it's in binary. But there's nothing stopping you from reading them. There are some permissions that you have to be able to write them because the operating system, the file system, has an understanding of what's supposed to be in them and what's not. So directories are just files, just like any other file. Now you'll notice up at the top that I have two files, bob.sql and bob, this is a file. You can argue as to what the extension of that second one is. Is it .file? Is it .a.file? Whatever you like, okay? But extensions are just part of a file name that happen to follow a period. A period is just a character in a file name. There is no special meaning applied to this. And that's just a string of values. There are some things that you cannot put in a file name because Linux uses a slash as a file separator. You can't have slashes. There are other things that you will find that you do not want in files, specifically blanks, tabs, files starting with minus characters. In general, the things that I would say that you don't want in file names are non-printing characters, like control characters, but especially blanks. Blanks are the most annoying, since they don't really serve any purpose in a file name. So, let's talk a little bit about how you change directories. Now, you'll notice that I have a bunch of directories already built. Pictures, public, templates, videos, but one of those is desktop, and the desktop that you see with the files on it, that's where that actually lives. Now, if I do pwd, I find out that I'm in home pschlump, which means that that's the path to get this to this. And if I do cd to desktop, and I do I typoed, left out a letter. There's nothing on my desktop at the moment, but if I do pwd, you'll see that I'm in home pschlump desktop. So if you want to go down into a directory, you do cd to that directory. If you want to go up, you do cd ... and that allows you to go up one directory level. Now, since we're not at the top, we can go up from here. We can do cd ... again, and we can be at home. You'll see that the only user on this system that's a regular user is me. And we can do cd ... again, and you'll see that there's a whole bunch of system commands or system directories like bin and lib and stuff like that at the very top level. There are plenty of things in here that you cannot change without being this special user called root. It is the owner of the operating system. Now, if you want to refer to your own home directory, you do a tilde. So cd tilde will take you back to your home directory. I hope you're noticing that the information over here in the prompt, the default prompt, is changing as I do this. So if I see cd to videos, I get that, and it says that I'm still, somewhere in my home directory / videos is the path that I'm at. There is this special directory called temp that is public to everybody and shared. That's where temporary files are put. And there are all sorts of configuration things and stuff like that if you want to change them, for instance, installing a new command on the system, that's going to require that you be root, or that you use a thing like sudo. Sudo takes your current command and makes it root after asking you for a password to be able to install it. Now, we can create additional directories. Let's go back to our home directory. If you just do cd, it takes you to your home directory. And I can do mkdir mydir, which creates a directory. You'll notice that mkdir, or mydir right there, now exists as a directory. If I do ls-l, okay, this is now a directory. It has a D in the first column. When you do an ls, you're going to see that these files have different sets of permissions. There is a set of 3. It says rw minus, then r minus minus, r minus minus. The 3 groups of permissions are, the first 3 are for the owner, as in can you read and write, that's the R and W. The third one is execute. Most of these things don't have the execute bit set. And then the second 3 is for the group that you're in. I'm pschlump the owner and pschlump the group. But quite often in a system with a database, what you have is you are a member of the database administrators group. So you can actually switch your group to be something that has access to a shared set of group files. The last one is everybody else on the system. Who has access to it that is neither the owner nor the group. This is a multi-user system normally. Unix and Linux are. So the assumption is that there are people on the system besides you, and whether or not you want them to be able to have access to your files. You'll notice that the Unix default is the assumption that your files are public to everybody on the system for reading, but not for writing. So you should be aware of that, and if you want to keep something private, then it shouldn't be just put on the system with the default set of permissions. You can change the permissions with a command called chmod to modify permissions of files. We'll give an example of that here in a little bit. But if you take a look at the files that we created, like Bob, this is a file, okay? That file has read-write for the owner, read-write in the group, and read-only for everyone else on the system. Now, the different columns are, we've got this set of permissions at the beginning as the first column. Then there's this number that's 1. Sometimes it's 2, you notice. We'll get back to that and what it constitutes. Then we have the owner of the file, the group owner of the file, the number of bytes in the file. Unix views files as just a big long bunch of bytes that happen to, well, if it's all characters that are printable, be a text file, and if they aren't all printable, well, it isn't a text file. But there's no particular differentiation. Then there is this date and time that is the last time that the file was modified. And then there is the name out here. Names can be arbitrarily long, unlike more primitive operating systems like Windows 10 that puts a limit on file name length. By arbitrarily long, I believe the current limit in the Linux operating system and its file system for the length of file names is 2 to the 32 characters, which is quite a bit bigger than most people's hard drives. So, that is kind of the stuff that you see when you do an ls-l. The L is for long, but there's a couple things that have been left out when we do this ls-l, and that is there are hidden files. If we do ls-la, you'll see that there are more files listed suddenly. And one of those files that is listed there is this funny file called dot. Dot refers to your current directory that you're in. If you are in a directory and you wanted to read the contents of it, say you were writing a program like ls, you would actually open to read the file dot. Dot refers to the parent of this file. And you'll notice that the parent directory of your current home directory is something that's owned by root. Now, that means that you can't directly change it because you don't own it. Then there are files like, especially this one, bash rc. RC tends to indicate that the file is called a run script, and it gets run by some program automatically at the beginning of execution. Now, when we sit here and we type a command, we're actually in a program called bash. So bash is the programming language that is interpreted, that is taking ls and doing whatever it does for ls to run it for us. And bash is a unique kind of a program called a shell that actually runs other programs. Most other things don't spend much time running other programs. When we write Python code, we're writing stuff in that language. There is a way to run stuff in Python, other programs, but generally speaking, you don't do that. You're writing code in that language. In bash, generally you're running other programs. ls is a separate program from bash, as is cat and other things that you've seen me run. But when I do ls-a, it gives me all the files. And any file that starts with dot gets skipped over when you just do a regular ls. But if you do -a for all, long all, then you get all the files. In particular, bash rc is the configuration file that sets up bash when you log in. And it has important things in it like the path. The way that bash works is it has a list of directories on the system where it goes and looks for other things it might run. It looks in order, and this is called the path. Windows has the same thing. It's set up on a system-wide basis. In Linux, it's each time the shell gets started, it goes and reads this thing. So if we go and look at this, there is a default system path. Okay, and there's no special path that's been set in here for us. But there's a whole slew of options that are set up. Okay, like this LA command, which is an alias. If we do this, okay, we'll see that we get not a long listing, but we get a listing of all the files, not just the ones that don't start with dot. Now, if we do ls-l of a particular file, we bring up that file, okay? I've walked you through what the different groups of commands are, but we can actually use chmod to change the permissions. For instance, maybe we don't want this file to be readable by anybody other than us. So we do chmod -o-r And you'll notice that now nobody but us can read it. Now, if I wanted to set up a file where the Postgres account could read and write the file so that I could use something inside the Postgres account, this is how I would do it. I have another file here that has this in it. It's just a create table, but let's say we wanted to make the Postgres account access this file. I could do O plus RW bob.sql. Now when I do, an ls of bob.sql, you'll notice that it's read-writable by everybody on the system. So if I'm some other account, I can actually change the contents of this file. Now, obviously, if you're making it so that other people can change a file, there are ramifications in terms of, them modifying your file when you don't want them to. So you should use that with some level of caution and decide what it is you want to change to make writable. When you want something to be, there is this third bit, it's read, write, and execute. When you want to be able to have a program run a particular script like Python, we can set the execute bit on it with a +X. And then there's a special thing that we can put in at the top, a hash bang with a path to that executable. And when we do that, we can take that and we can run that command. For instance, I can create a script. If I do x.sh, we'll just put in echo hi. This is the hello world of bash scripts. And up here, I put in hash bang /bin bash. I know that bash happens to live in that location. And then I can do chmod +x x.sh. And I can now do /x.sh. And it says hi. I've actually written a program in the bash scripting language and made it so that the system can run it. Whenever you have a pound exclamation at the beginning, it's expecting that to be a path to execute something. If I do an ls-l on this, you'll see that this now has an execute bit set for everybody. It has execute for the owner, the group, and others. It still doesn't have writable to the world, but now anybody can execute it. All right. So if we knew where we had Python, we could do the same thing for Python. We could build a little Python script that we could just run. Now you'll notice that a couple of times I've said // here. // says in the current directory, remember that's dot, follow the path after that to this file. And the reason that I had to do that is because I don't believe that my current path includes the dot directory. There are security ramifications for doing this, but let's go change the path. I believe it is a semicolon for the path in or a colon for the path in bash, but we will change the path and we'll run this and we'll find out. And now my path, which is separated with colons, has a dot in the beginning of it. So if I do x.sh, it finds it in the current directory and it runs it. So if you have some piece of the path that you need to change, you can go into your .bashrc and you can add that in there. For instance, if I install Postgres and it doesn't get set up with PSQL, the command line interpreter for Postgres, in my path, I can go in and put in the directory where it was installed, and it will search that directory where the executable is and find that using the path. The same thing applies to Windows, that you can go change the path and you can add commands that it will search for in the Windows path. Now, when we look at other things, one of those things is you can combine these paths into longer paths. So I can do ls of ... That was the directory above me. I can do ls ... That is 2 directories. That's actually the top level directory. An interesting thing happens at this point. If I do dot dot slash dot dot slash dot dot, you'll see it gave me the same thing. And if I do it again, the top level directory at the very top of the tree just points at itself. It doesn't go any higher. So you can add as many dot dot slashes as you want, and it doesn't go any higher. Now, anytime I have a directory, I can combine these paths into a longer path. So if I have some directory that I want to look at, I could do ls of dot slash desktop dot dot slash dot dot. So I went down 1 directory, I went from the current directory down 1 directory, then up 2. And guess what? That canceled out some of the stuff and I went back up 1 directory. Whenever I'm referring to files, I can always refer to it in this fashion. These things with the dots and dot slashes can take me up and down the tree to find files. Now, when I want to use a particular account, I've installed Postgres on here, but I'm not in the Postgres account. So I want to be able to get to the Postgres account. I can use a program called SU with an option -L to log in. And that says not log me out, but log in as a new shell on top of my current shell. But this requires that I can actually log into the account. So if I do SU -L Postgres, it prompts me for the password. Now, Postgres is not a login account, so it doesn't have a password, so you can't enter one. What you have to do is you have to become root. Now remember, there's this special command sudo that allows a particular command to become root when I enter a password, and then I can do SU -L Postgres. Now what I did to get out of that password prompt is I did a Control-C, which cancels things. It asks for my password, which I'm granted the permission. If I enter my password to sudo to become root temporarily, then it runs the SU command as root. And when I do this, okay, suddenly I'm in a new account. Now you'll notice my prompt changed from pschlump over here to the Postgres account on this particular UB18 system. If I do ls, in this particular system, I have one version of Postgres installed, version 12, and I seem to be, when I log in this directory, varlib Postgres SQL. Now the Postgres account has special permissions that it uses to be able to allow you to administer the Postgres system. And there are files that it owns that only it can change, like how the security is set up and what constitutes valid login types for your database. And also, this is the account that owns all the actual data on disk for your database. So these files are not accessible from any other account, but you need to use care in using this account because, you know, if you delete some of the database, you broke it. So in this particular thing, I can do PSQL, and when I log in, I've gone from the user in the Linux system Postgres to the user in the database Postgres. Those are 2 different things. There's a system Postgres, and there is inside the database a special account called Postgres. That database account has all the privileges to create other accounts. So inside the database, I can now go along and create different accounts in the system. One of those accounts that I want to create, okay, and I'm getting down here in my notes to where I do create the database, is to create a database for this particular user. I already have this database created, so I'm actually going to create one for new user. But basically, when you do create database, you want to, instead of putting new user there, you want to create a database for your account, like pschlump or whatever your account name is in your system. Creating a database creates a basic shell for that database that has the necessary stuff to be able to log in or use that database with a set of tables. It creates a space for that. Now, when I do this, I can also associate with this a database user. So I can do create user. Again, if you're doing this for your own account, you want to use your username, not new user. That's a terrible password. But you'll notice it just accepts it. And this, and I mistyped privileges. Okay. The database has a system of protections, permissions, so that users in one account in the database can't change other people's data, tables, stuff like that. And what I did is I just granted lots and lots of privileges to new user. And I do a \Q to get out of PSQL. But I've gone and I've created this user. If you do this with a Unix account name instead of new user, where it matches the account name, this means that when you go to that user, you should be able to do PSQL, and you'll notice that you're now in the database user that matches with that Unix account. That's the expected default for creating these users and databases, is that you're able to create and access this directly from your Unix account. Now, inside this account, I can do nice things like run files. I have that one file, Bob, that has 2 columns now because we changed it. But if I do \I, bob.sql, I've created a table. So I can do \D, which describes tables, and I can describe Bob and find that it has some columns. I can insert data into it. I can drop it. I can do useful things like that with the column or with the table. So this is how you get files onto the system, create tables in the database under your account. I think that's all I had to say about creating files and copying them back and forth. You know, it's something that you should have some practice with. I use the VI editor on stuff. There's good reasons for using the VI editor. It's a hard-to-learn editor, but then playing the violin is a hard-to-learn musical instrument, and it's not an easy-to-use thing. It's powerful, and violins have tremendous capability, just like the VI editor. So if you want to learn how to use VI, as opposed to other editors, I suggest that you go search for a VI tutorial and practice with it. There's very good interactive tutorials on the web for it that allow you to walk through the basic commands in VI. And why would you want to take the time to learn VI as an editor? That's because it's everywhere, and I'll give you a motivation that I have for using it. Some years ago, Stack Overflow did a survey of developers and what they got paid for, and it found that on average, the ones that use VI make $14,000 a year more than the ones that don't. So there may be something to this. I know about 2,000 different commands in VI and use them regularly. There's at least 3,000 commands. So when you're talking about thousands of commands, it's not this. It is a trivial thing to learn in 5 minutes. The other thing is VI is on everything, and consequently, I can work with it on most systems. It's not by default installed on Windows systems, but there are Windows installations for it. But Windows is not the world's most common operating system either. Unix, Linux systems are far more common. There's way more systems out there that are running that than Windows. So when I say it's on everything, you know, it is on my router, my desktop, my systems, my virtual systems. All of these different things have VI, and it's really useful. And it works well at remote distances. So it's a very useful thing to know. And it's certainly not the only way to edit. I also use VS Code. I sometimes use other editors as well. But it's my day-to-day editor that I use for most stuff. Okay. We'll call it there.